In this video, we are looking at exponential growth functions. And if you consider this equation, y is equals to b raised to x, a cannot be 0, b has to be a positive number other than 1. If a is greater than 0 and b is greater than 1, then this equation represents an exponential growth function, and b is called a growth factor. So let's look at this function here. You can, if you're given this function, to graph it, you just need to get some values. You need some x values which are negative, and then some positive x values in the domain. Then you get the y values. And you can see the points. You connect them with a smooth curve. And from what you see here, you can be able to tell the y-intercept is 0, 1. The domain is, this graph continues indefinitely. So the domain is from negative infinity to positive infinity. And you can see the range, it starts from, it gets a little close to 0 but doesn't get to 0. So we're going to say from 0, but 0 is not included, to positive infinity. And the equation of the asymptote, the line which is not being touched, is y is equals to 0. And the growth factor is 2. So this is how a growth function looks like. So right here, we are told to transform the exponential function. So we are given the parent equation, and this is the general transformation equation. You can see the x minus h, k. So we have a, h, and k. So those are the variables which are going to transform the graph. And here we are given two graphs, and we are told the parent function is 2 raised to x. Remember, it doesn't always have to be 2, it could be any number. That's the parent. And then we are supposed to identify all the transformation from f to f prime. And then we write the equation of each asymptote, find the domain and range. So let me start by naming these graphs. So this is f, and this is the transformed function f, and f inverse. And here, let's talk about the transformations, and we're going to look at this equation. If I look at this equation, I'll be able to identify the value, what variable I'm looking at. And from what I see here, I'm looking at h, and here the h value is 6. And what does that mean? It is a horizontal shift to the right, 6 units. And for this one here, I see that h is equals to -5. So this one goes to the left, 5 units. 5 units to the left. And we also need to write the domain and range. And the domain and range is the same for both functions. So I'm going to write the domain and range for both. It's going to be from negative infinity to positive infinity. So that's the domain. And then for the range, for both of them, it's going to be from 0 to positive infinity. And then the equations for the asymptote are the same for both. So the equation of the asymptote is y is equals to 0. Or you could say here the x-axis. So let's look at another example here. So for this graph, we are going to do the same thing, but I need to identify what I have here. So I see I have H and I have K. And let me talk about this graph. So I can see that H is equals to -3. So how is that going to affect the graph? So it's going to go to the left 3 units, and I'm also given K. K is -4, so it's going to go down 4 units. So those are the transformations, and I can also write the equation of the asymptote for the new graph. So remember, this is the f function, the transformed function, and this is the parent. So here, the transformed function, so the domain is the same, -infinity to +infinity. So what about the range? The range is from -4 to +infinity, and the equation of the asymptote is equals to y is equals to -4. That's the line which is being approached. So let's look at, and from what I can see here, the equation of the asymptote is given by, if I can summarize that here, is given by y is equals to k. Y is equals to k. That's how I get the equation of the asymptote. Okay, the next example right here. So here I can see there is refraction. So I'm going to say refraction over x-axis, refraction over the x-axis. And what else do I see? I see it has moved. Remember, this is the original function, the parent. This is a transformed function. I can also see that it has moved up 1. So it has moved up 1 unit. And so those are the transformations. So the equation of the asymptote, I'm going to denote it by that, is going to be y is equals to k value, which is y is equals to 1. And let's write the domain. So the domain, see, the domain stays the same for these functions, but the range is generally given by, for this one, the range is going to be given by 0. So you start from -infinity, because you always start from the bottom up to whatever k value you have. This is going to be -infinity to +1. And if I go back to the one I did here, and I'll use a different color, I want you to see that the range is given by k, whatever k value is, to +infinity. That's a general way to remember it, so that when you see the equation, you are able to write the domain and range by looking at the k value. You can be able to write the domain by looking at the k value. Remember, the domain is always all real numbers, but for the range, just focus on the k value. So here we are given another equation. So we are going to be doing the same thing. Remember, this is f, this is the transformed function. And what I see here is that a is equals to 3. Remember what a does. A does what we call the vertical stretch. Remember, if A is greater than 1, so we have vertical stretch. If A is less than 1, so this is going to be vertical shrink. Vertical shrink. So the one we have here is just vertical stretch. And we can write the equation of the asymptote. Equation of asymptote is just y is equals to 0. Remember, the domain is negative infinity to positive infinity. And again, range given by the value of k is going to be from k to infinity, specifically from 0 to positive infinity.